Uh, Hello friends, last class I discussed about the introduction to organic light emitting diode, that is OLED, right? So I have given you the brief idea about the organic light emitting diode. Okay, so now I'll discuss about the development of OLED. So before going to discuss about the how history of the OLED, so before that I would like to share before OLED what kind of the lighting systems were available, right? So different kind of the lighting system I will discuss. So there are lots of disadvantages, advantages. So some lots of drawbacks can be overcome by the organic light emitting diode. Okay. So before developing of the organic light emitting diode, so first is the lighting system. These are the lighting system. So now I want to discuss about the some lighting systems. Okay. CRT, that is cathode ray tube. Okay, cathode ray tube. It is first discovered in the year of 1930. Okay, in the year of 1930, cathode ray tube was discovered. Okay, for evaluating some kind of the informations, or for evaluating some kind of the informations and some kind of the signals, and for observing some kind of the different informations. Okay, so cathode ray tube is nowadays also cathode ray tube is used for observing or for evaluating some kind of the informations like sinusoidal information, different kind of the analog informations, right? So after 1934 CRT-TB was discovered. Okay, sorry, 1944 CRT-TB was discovered. Okay, so it has how it can be designed. Okay, normally it is designed, okay, by employing electrodes and insulating layer. Insulating layers. Okay, but it has some it can show, it can give you the light, and we can see it can be used for display systems, and we can see the information by using the cathode ray tube. Okay, there are some radiation efficiency or photoluminescence efficiencies, but it has some drawbacks like bulky nature. Okay, bulky nature, slow response speed, response time, okay, and short lifetime. Okay, so this lifetime, that lifetime is one of the important factor if you want to design any kind of the display systems, right? Okay, so these are the disadvantages. So to overcome these issues, after CRT, fluorescent lamp was discovered. Okay, fluorescent lamp was discovered in the year of 1930. Okay, fluorescent lamp discovered in the year of 1930. Okay, now 1930 fluorescent lamp was 1932 fluorescent lamp was discovered. Okay, so what are the materials are there inside the fluorescent lamp? Okay, so normally the fluorescent lamp, it can be designed, so it can be designed by glass chamber. It can be designed by glass chamber. Suppose this is one kind of the glass chamber. Okay, so the entire glass chamber, that is filled with the inert gas. Okay, and the entire glass chamber, this is coated with the phosphorus and mercury. Okay, now how the light will produce from the fluorescent lamp? Okay, so how we have to apply some bias or by external signal, so that the mercury and phosphorus can evaporate. Okay, so the vapor of the mercury, that will produce UV light. So vapor of the mercury will produce the UV light inside the chamber. Okay. Now this UV light that will mix with the phosphorus vapor. Okay. The UV light that will intermix with the phosphorus vapor. Okay. After that, the intermixing of UV light and the phosphorus vapor, that will give you the light or optical signal, that is visible signal. Okay. So this is the normally principle of the fluorescent lamp, right? So it is also commercialized later. Okay. Later the fluorescent lamp was also commercialized like CFL bulb. Okay. But the CFL bulb, this is also costly and the short lifetime. Okay. Very costly and slow lifetime, low lifetime. Okay, and slow response time as well. Right? So after that, inorganic LED. Okay, LED, all of you know the popular name of LED, light emitting diode. It is easily available in the market. Okay, we can use the LED in different applications. Okay, in home and display applications we can use the LED. Right? So that is inorganic LED. After fluorescent lamp, inorganic LED, that was discovered. Okay, that was discovered I think in the year of 1940, and it is totally commercialized in the 1960. The inorganic LED that is totally commercialized. Okay. Now inorganic LED. So LED, that is a light emitting diode. So normally it is one kind of the PN junction. So we have to apply the forward bias to generate the light. So last class I discussed about the electroluminescence effect. Okay. So LED, that is mainly totally driven by the electroluminescence effect. Okay. So inorganic LED, that means the LED that is made up of the inorganic semiconductor. Okay, you like group 3,5 compound from the periodic table. Group 3,5 compound from the periodic table like aluminum, gallium arsenide, gallium phosphide, silicon carbide. This kind of the compound semiconductors can be used for designing the light emitting inorganic light emitting diode. Okay, so it can give the fast response time as compared to the CRT and the fluorescent lamp. Okay, in fast response, and we can get the high contrast ratio, and easily we can use for different home applications and display applications. Okay, now so some small viewing angle. You want to use for high radiant system, and the wide viewing angle we cannot use. Okay, it has a small viewing angle. Okay, so again, if you design inorganic LED by quantum dot, we design inorganic LED by quantum dot, you will get the higher response time and the higher photoluminescence efficiency. Higher photoluminescence efficiency. Okay, and high long short lifetime. Okay, now but it has one disadvantage, that is self quenching effect. This is the drawback. Okay, self quenching means, so normally you have to produce the exciton inside the light emitting diode to produce the light. Okay, so this exciton that will not emitted properly from the system. It will be penetrated in a somewhere in the trapped state. Okay, it will be trapped by the other states. Okay, so we will not get the exact amount of the excitons from the inorganic LED. That is the self quenching problem. Okay. To overcome these issues, another lighting system that was discovered, that is LCD. Okay, it has wide applications. LCD, liquid crystal display. Okay, so it is discovered in the year of 1982. Okay, in the year of 1982, liquid crystal display, that was discovered, and it has wide application. So in the in the watch, TV, different displays, different kind of the display system. Say watch, TV, and many more applications are there. Okay, now again we can design the LCD by using the quantum dot. Okay, we can use the other inorganic semiconductors also, right? But so for getting the better performance, we have to use the quantum dot. Okay, if we use the quantum dot, we can get high lifetime and response speed, and the wide viewing angle. Wide viewing angle means, so if we make any kind of the display system, okay, you can see from anywhere from the room. Okay, that is a wide viewing angle, right? So these are the advantages if we use the LCD. So LCD, that is mainly LED, inorganic LED, that is used for normally illuminating lighting applications. Okay, but LCD, that is mainly used for the display application. Okay, both are almost same advantages, disadvantages, right? Inorganic LED and LCD, both are comparable. Okay, now nowadays we need a flexible devices. Okay, we need a flexible devices and uh, lightweight, low cost devices. Okay, mainly lightweight, thin, lightweight. Now you can see, so day by day, normally day by day you can see the many more mobiles and laptops are discovered. Okay, so these are the very lightweight and very thin. Okay, so these are the parameters are required, and we have to remember these parameters if you are going to design any kind of the devices. Okay, so now this, so main is the flexibility, less flexibility issue, and the heavy weight. These two are the drawbacks for all the lighting systems or display systems except organic light emitting diode. Okay, organic light emitter, it has some lifetime issue, but apart from the lifetime, you can get a high photoluminescence efficiency, high contrast ratio, high flexibility, low cost, and the lightweight. Okay, these features you can get from the organic light emitting diode. Okay, so day by day how organic light emitting diode is discovered and how it is commercialized, this I will discuss on the next class. Okay, so this is about the history of the lighting system and the display system. Thank you.